All right, today we're going to be taking a look at exponential functions, how we can create these things, and how we can use them, drawing them from a table, and then maybe even discussing a little bit of how we can interpret their answers from a graph. First thing I want to talk about before we get into this is the formula that we use. Again, the exponential formula, the f of x that we're going to talk about here, is the a sub 1 times the rate to the x power. Now remember, this is the change we're going to see from output value to output value, and this is going to be the value in which we start, and this will be the number of steps that we take. Basically what we're saying is how many times did we actually use this rate. That number can be 0, can be negative. So let's just get into these. These are straight off of your Delta Math first 4 or 5 assignments, so if you want to get those, that would be a wise move, but here we go. First one we're looking at here, we're given a table, as you can see, and what we're going to try to do is determine what our rate of change is, what is our function, where is it starting, and then we're going to test to see if this function actually works. So the first thing we want to take a look at is to make sure that it is an exponential pattern, meaning that it has a common ratio or a common rate as we move through here. So all we need to do in order to do this is take the term in front and divide it by the term behind it. And we do this each step of the way. Divide, divide, divide. So what we would do to check our common rate here is we would divide 1.5 by 3. So what we would have here is 1.5 divided by 3. And what we would learn is our rate is 1/2. We want to reduce that thing. I mean, it's not a necessity. I mean, you can have different rates, but a lot of times it's confusing. So we can see our rate here is 1/2. And then we move to the next one and we go 1.5. We're going to divide 1.5 into 0.75, which is also a 1/2 rate. Then we will divide 3.375, excuse me, .375 by 0.75. And then this is also 1/2. Don't be confused just because that number is going down. That has nothing to do with negative. When we have a negative, that's when we're jumping back and forth from negative sign to positive sign. So in our 3 parts we talked about, we've got our function, which we're writing, and we will have our starting amount, our rate, which we just found, and then our power. Let's stick with x. We're not dealing with sequence anymore or series, so we'll stick with the variable x. And I also said f of x, so I can't be changing the variables midstream. So what we have so far is our rate, which is 1/2. Decimals are the same as a fraction. That's just up to you. Now we need our starting amount. Now, it doesn't just mean the first one in the thing. What it means is the function when the x value is 0. Now this is actually in our list. The 3, x value of 0 does equal 3. So our starting amount here is 3. And that would be our value that we're going to put in front of our function. Remember, if it's 1, it can be left as an understood value, but that's what we have. And then our variable, because we are constructing a function, is just x. Now, it's always wise to check these. You can go in and plug these in and see that they work. Like if I were to plug in the f of 0, we would have 3 times 1/2 to the 0 power. Remember, that a 0 power is not 0. A 0 power is 1. So this ends up being 3 times 1, which is 3. So it does work for our first one. And what you want to do is plug those in for the subsequent answers as well. If I went to f of 3 and plugged it in, it would be 3 to a 1/2 power to a 3. When I plug this into my calculator, I should get the value 0.375. So therefore my function will be 3 to a 1/2 to an x power. Let's move on to the next one here. It says write an exponential function in the form a b to the x power that goes through the point 0, 15 and to 240. Now this is probably one of the more challenging ones that we have. What we need to be aware of is the fact that this function, first of all, we know our a value because we have the 0. So our function is going to be y equals the a value, which is 15. We are starting at 15. So now we need the rate, and then what we'll do is we'll plug in the x. So what we need to do in this case is, like on the last one, we have to divide the answer by the previous one. So in this case, that would be 240 divided by 15. So what we have is 240 divided by 15. And what I'm trying to measure is the amount of change in the y. The amount of change that took place in the y. Well, the amount of change that took place in the y is a 16. That is not my rate, however. Hopefully you notice that our x values here, we didn't go from 0 to 1, we went from 0 to 2. You got to avoid the temptation to say, well, 2 steps, so we're going to divide by 2. Well, each step is not addition in this case. Each step is multiplication. So we've had a change of 16, but that change has taken place in 2 multiplications. Not 2 additions, but 2 multiplications. If it were 2 additions, we could just divide by 2. So this has been multiplied twice. So what we have to do is take our result and take the root equal to the amount of steps. So I have 16 and I'm going to take the root. Remember, the index can change. However many steps you take, that's the value that goes inside of this index. So if we took 4 steps, it would be a 4th root. In this case, luckily, we only took 2 steps. So this is going to be a square root. I know we don't have to write a square root, but I'm going to, just to make sure that you're aware of it. Remember, the square root is understood. So what we find here is our rate is actually 4. Our rate is actually 4. So we're going to put our 4 in right here. And it's always wise to come in here and check your answers. So I'm going to go ahead and put the f of 2, because remember, f of 2 should have an output value of 240. So when I put this in my calculator, I do get the result of 240. And again, what I put in my calculator was this. And you could also plug in the 0 as well, but the 0 is pretty self-explanatory. If we remember that our powers of 0 equal 1, this would be 15 times 1, which of course is 15. So what you got to remember is however many steps is going to be the index of the root. 4 steps is a 4th root. All right, next thing we're talking about, we go from probably the toughest one to the easiest one. Given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. Let me just put a real nice little star for you by that one. It's the decrease that gets people, not the increase. All we need on this tells me where we start, this tells how many steps we take, this is what tells me what my rate is. But you've got to remember this, one simple thing, your rate starts at 100%, the number 1. So what we have to determine is how far away have we deviated from the 1. When it's a growth, that's really easy, just take 1 away. So if I'm at 1.2, well, take away the 1, you're at 0.2. So what we have here is, again, percentages. This is a decrease, and the reason why it's a decrease is because my rate is lower than 1. So this value right here will not be a growth, it will be a decay. And the amount of decay is not 0.365. a lot of people are going to put in that answer. Make sure you think this through. If I'm at 36.5% and I started at 1, well, I have decreased by 6.35%. But again, I said that wrong. I decreased by 0.635, which when I convert that into a decimal, I move my decimal place over twice. That leaves me with 63.5%, which is my value here. Make sure you always read. Make sure that it doesn't tell you to round. It says determine the percentage rate. Didn't ask me to round, so we're good to go with this answer. And then the last one, actually putting practice. It says a town has a population of 7,000 and grows 4% every year. What will be the population after 13 years? Again, the three parts, what we're looking for. First of all, let's put our function back together. We are starting at 7,000. We are changing by 4%. Now, don't put a 4 in here. That's a 4 to the 4th. The nice thing about these is if you do make a mistake, it's pretty easy to tell that there was a mistake there. This will not let me erase. There we go. So fight that temptation to put that in there. And then also fight the temptation to put in 0.04. Because the population is growing, we are adding to that to the 100%. So this would be 1.04. And then we don't know how much time when we're creating the function. But they don't want us to create a function here. They want us to solve one for 13 years. So what we have here is a population of 7,000 changing by 4%. That would make it 104% change, and doing it for 13 years. So I put this in my calculator, and what it tells me is 11,655, and it actually says 0.51, but we're talking about people here, so we can't have 51% of a person. We go back to our instruction, it says round to the nearest whole number. So the 5 is going to kick us over the top, so this would be 11,656.